Today's activity is from your textbook. I've modified these problems slightly, so do them from below instead of from your textbook. 19, solve the equation exactly for 0 less than or equal to t less than or equal to 2 pi. Tangent of t equals -1. Okay, the fact that it says solve exactly means that tangent must equal -1 at some nice angles, meaning look at your unit circle. So again, we'll take our look at the unit circle, and we're looking for tangent of t equal to -1. So we'll write that equation here. And we know that tangent is y over x. So we're looking for places where the y divided by the x is -1. The only way a fraction is -1 is if the two numbers, top and bottom, are the same but opposite sign. So we're looking for the same numbers but opposite sign on the x and the y. So for example, here the numbers are the same but they're the same sign, so that's not going to work. But if we take a look over here, we'll see two numbers that are the same but opposite signs. So that's one winner right there. So 3 pi over 4 is a perfectly good answer. And then we want the same but opposite sign. Nope, those are the same and the same sign. Over here, yes, same and opposite sign. So then the other answer, the other fundamental answer is 7 pi over 4. So we said that we had 3 pi over 4 and 5 pi over 4. So we'll write down our two answers. And we'll just say from the unit circle. We get t is 3 pi over 4, and t is 7 pi over 4. 28, find all solutions of cosine theta equals -0.4226 for theta between 0 and 720 degrees. So for this one, definitely not going to find this number on the unit circle. So we better start thinking about inverse trig. So we'll copy that equation again with a telltale space in front of the right-hand side. And in that space, we're going to put the opposite of cosine, which is inverse cosine. And then on the left-hand side, inverse cosine and cosine cancel, and we just get theta equals. Okay, so clearly this is a calculator part, so let's type this into the calculator. We have that, but again, anytime you use one of the three trig buttons, we got to make sure that we think about our mode. This problem says take a look between 0 and 720 degrees, so we are in the wrong mode. So we go to degree mode, we will get 1 and only 1 degree answer. It's about 115 degrees. So let's write that. Okay, so that's one answer, but remember that there are generally two fundamental answers. Almost every trig equation will have two fundamental answers. So let's think about our unit circle. And we're looking at 115 degrees. So maybe that's around here somewhere. And this is a cosine, and cosine is the x coordinate. So apparently the x on that point is special, and we need to find the other point on the unit circle with exactly that same special x. So the x is right there, whatever this distance is, and the other special point on the unit circle is down here. So that guy right there has exactly the same x. And then we'll go ahead and draw it to the origin, and so then the other answer that we're looking for must be this one. And now we really have to think about symmetry in order to figure out what that green angle truly is. There are a couple of different ways to figure out what it is. I'm going to encourage you to make use of something called the reference angle, which we'll talk about some more next class. The reference angle involves finding this angle in here. So if it's 115, then we can subtract 180 and get that in here is 180 minus 115, or 65 degrees. And if that's 65 degrees in there, then gosh, it sure feels like this in here is also going to be 65 degrees. And so that means that the green angle is going to be the 65 plus a half a revolution, 180 degrees. So the green angle is about 245 degrees, and now we have our two fundamental answers. And then we know that we have an infinite family of, two infinite families of answers based on these two different angles, 115 and 245. And so all we'll do is add 360 as many times as we please to each of these things. And we're just trying to get up to 720. So it feels like we're just going to add 360 once to each of these guys, and we'll have our answers. So let's just write our final answers here. 115, 245. And then we're going to add 360 to 115. And so that gives us 475. And then we're going to add 360 to this guy. And that gives us 605. And you'd be free to add many more 360s. But as soon as you add another 360 to this one, you land on something bigger than the 720. So we've got our final answers here. There are 4 answers to this problem. 2 fundamental ones, and then another 2 that come out from just taking extra revolutions around the circle. Okay, number 10, approximate the solutions to the equation cosine t equals 0.4 between negative pi and 3 pi. Okay, same idea as before. You're not going to find 0.4 on the unit circle, so this better be an inverse trig thing. Copy the equation, but leave the blank space. Put the thing that's the opposite of the cosine. Cancel inverse cosine and cosine. And here's the one time we use the calculator. Well, first time, I guess. We'll use it a few times in this problem. So we're doing inverse cosine of 0.4, and we get this. And if you're really not, I guess I would say that there's no way to know that that's the wrong answer unless you're really on the ball. And so I'm just going to stick to my guns. Anytime I hit sine, cosine, or tangent, I immediately think about mode. And in this case, I'm in the wrong mode. This one says we're looking for answers that are between negative pi and 3 pi. Clearly, this is a radian problem. So we got 66 degrees before. That's not the right version of the angle. So about 1.16 is our answer. Okay, so now we've got to find the other fundamental answer. So that's one of them. So to find the other one, we'll draw our old friend, the unit circle. Okay, 1.16, which quadrant is that even in? Well, remember we said that up here is pi over 2, which is around 1.57. And over here is pi, which is about 3.14. And down here is 3 pi over 2, 4.57, I think. And then over here, we're back around to 2 pi, or 6.28. So where's 1.16? Well, if you have these decimal versions instead of the pi versions, then it's pretty easy to see. Well, 1.16 is definitely smaller than that. So it's got to be in here somewhere, but it's not halfway. If you want to be kind of to scale, then maybe someplace up there. So we'll say that this angle is about 1.16. And there's something special about that point. Is it the x or the y that we're focusing on in this problem? So this equation right here is cosine t. And we know that cosine is the x, so apparently the x at this point is important. So we're going to drop straight down to say that this is really the x we're interested in, whereas the other point on the circle with exactly the same x, continue straight down, it's this guy. So then we'll draw in here. In blue, the angle that we really want is this one. And how do we find that angle? Well, I guess we can just take 2 pi and subtract off the 1.16, because we better believe that in here is also a 1.16. So then the blue is equal to, what do we have? 2 pi minus the 1.16. Okay, just because I might use this angle again, I'm going to call that one, let's call that one A. And then we'll do 2 pi minus that number. And we'll call this guy B, and this is our other fundamental angle. So about 5.12 is B. Okay, so we've got our two fundamental angles, but we're looking for all the angles between minus pi and 3 pi. So we're going to have to tweak these angles a little bit. So for example, if we go back to our 1.16, we know we can add or subtract as many 2 pi's as we want to. So what if we subtract a 2 pi from this guy, and we'll subtract 2 pi from this guy, and just see if either or both of them live in this domain. So what if we do a minus 2 pi? And I think that's too small because the domain again is from minus pi, and minus pi is negative 3.14, and that's too small. So a minus doesn't work, but what if we did b minus 2 pi? Remember, you can take these guys and add or subtract as many 2 pi's as you want. And that looks pretty good to me because that's definitely inside of here. So let's write that as another answer. T equals the 5.12 subtract off 2 pi. And we get negative 1.16. So that's another perfectly good answer, which actually makes a lot of sense, right? That's just this angle going the clockwise way instead of going around this way. Okay, that's fine. And so I think we're done subtracting 2 pi's. So why don't we just start adding 2 pi's now? So instead of doing a minus 2 pi, we'll do a plus 2 pi. 7.44, that seems like a perfectly good answer. And we could just as well have done our 5.12 and added 2 pi to that. And we get 11.4, which actually is too big because we know that 3 pi is the top of our domain, and that's only about 9.5. So I think we've got our answers. There are 4 of them in this case, and I will highlight them in blue. 2 fundamental answers were these two. Then you add or subtract as many 2 pi's as you want and get the rest of them. 33. Find all solutions to the equation sine x equals negative 0.8 in the interval 0 to 4 pi. Okay, again, negative 0.8 is not a nice angle on the unit circle, so we're using inverse trig. Leave the space. Fill the space. Cancel. And then rewrite the equation. Okay, here we'll use the calculator for our approximation. Before I hit enter, think about the mode. This problem says 0 to 4 pi, so we should be in radians, and we are. So one fundamental answer is this thing, negative 0.927. Okay, so that's perfectly good. And then we'll draw the unit circle to get the other answer. The other fundamental answer, I should say. So remember we had said that up here at the top was about 1.5. So at the bottom, if you go the other way, it's about negative 1.5. And negative 0.9 is somewhere in there. So a very quick sketch tells me that this is one of our fundamental angles, negative 0.927. And then we want the other one, but we got to do a little bit of analysis here. This is a sine problem. We know that the sine is the y value. So apparently the y value at this point is important. And where's the other point on the unit circle with exactly that y value? Continue on to here. We get this point. Okay, so let's go ahead and draw in then this line and know that the other fundamental angle is this one here. Well, if it's a negative 0.927 on the right, then I guess by symmetry, this one is also going to be a negative 0.927. Although we'll get rid of the negative and just call it positive 0.927. We'll go the positive way, whichever way that is. And then we'll say that blue is definitely equal to a half a revolution pi plus the 0.927 that we've already got. Okay, so how about we store this thing as a before we lose it. And then we're going to add pi to this. Oh, we got to be careful here. We're going to negate that number. So we're going to do pi plus, and then negative a. So I think that'll turn it into a positive 0.927, and that seems okay to me. 3.14 plus the 0.9, so that's right. 4.067. So that's our other fundamental answer. Let's store that as b before we lose it. Okay, and then all we have to do is add or subtract as many multiples of 2 pi as we want. We are just looking for the answers that are between 0 and 4 pi. It seems like we have 2 of them so far, 4.067 and negative 0.927. But wait a minute, this guy is negative. It's actually, even though it's one of our fundamental answers, apparently instead of going this way, we were supposed to go around to here. No problem. We'll just add 2 pi. It's the same basic rule. Just add or subtract as many 2 pi's as you want. So we'll write down here another x is negative 0.927 plus 2 pi. So let's do that up here. That was the a, negative 0.927 plus 2 pi. There's a perfectly good angle that's in the domain for us. So 5.356. Just for kicks, let's see if we can squeeze another 2 pi out of this one. Add 2 pi more. 11.63. Is that more or less than 4 pi? Actually, I think that's a little bit less, right? Because pi is around 3. So 4 pi is 12 and change. So that answer is another perfectly good answer. So x equals the previous 5.356 plus another 2 pi gives me 11.639. And if we go another 2 pi from that, that's definitely too greedy. We can just get 4 pi in front of us to make sure we know what the max is. That's the top. So then the other thing we're looking for is just the other fundamental angle, which was around 4. And we'll just add a bunch of 2 pi's to this thing until we get bigger than the 12.56 that's on the calculator. So I think that the 4.067 is still stored as b. Double check that by just typing it. Great. So then what we're looking for is b plus 2 pi. And that 10 is definitely smaller than the 4 pi, the 12.5. Let's see if we can push it, add another 2 pi to this thing. Nope, that's too big. 12.5 was the top. 16 is out of the range, or domain, I should say. So 10.352 is our other answer. And that came around from taking the 4.067, adding 2 pi, 10.352. Okay, again, we have 4 answers. I will highlight them. That 5.356, this 11 and change, 10 and change, 4 and change, and that's it.